Welcome! In this video, we would like to demonstrate the use of this Bayes theorem to calculate some conditional probabilities. The Bayes theorem is very useful in the sense that sometimes it is more natural or easier to know the information that event A happened and we wish to know how likely that event B occurs. But it is rather difficult or unusual to know the information that B happened and we wish to know how likely that A occurs. Then the good thing about the Bayes theorem is that it helps relating these two conditional probabilities by alternating the roles of A and B. Instead of the need to assume the information that B happened, we just need to assume that A happened, which is more natural in some situations. In the following few pages, we would like to demonstrate the use of this Bayes theorem to calculate some conditional probabilities. Let us refer to this example. Before we discuss question A, let us refer to this diagram. So according to the question, a fair dice is thrown once, therefore the number that's come up is equally likely. And if number 2 or number 3 appears, then we will pick box 1 and a ball will be drawn from this box. Otherwise, if the number that comes up is 1, 4, 5, 6, then we will pick box 2 and a ball will be drawn from this box 2. Therefore, from this information, we notice that the probabilities that we will pick a ball from box 1 will be equals to 2 over 6, which is 1 over 3. The probability that the ball will be drawn from box 2 is equals to 4 over 6, which is 2 over 3. Now, we notice that box A contains 3 red balls, 4 white balls, 3 black balls. So, given that we have chosen box 1, then the probability that a red ball is drawn from box 1 will be equals to the number of red balls divided by the total number of balls in box 1. Assume that it is equally likely to draw the ball from box 1. And therefore, the probability that a red ball is drawn given that the ball is drawn from box 1 is equal to 3 over 10. Likewise, the probability that a white ball is drawn given that this white ball is drawn from box 1 is equal to 4 over 10. That is 2 over 5. And the probability that a black ball is drawn given that it is drawn from box 1 is equal to 3 over 10. And from the question, we notice that box 2 contains 4 red balls and 6 white balls. Assume that the chance of picking each ball from this box is equally likely, then the probability that a red ball is drawn given that it is drawn from box 2 is equal to 4 over 10, which is 2 over 5. Likewise, the probability that a white ball is drawn given that this white ball is drawn from box 2 is equal to 6 over 10, which is 3 over 5. Now, if we want to find the probability that a red ball is drawn, then it can either be drawn from box 1 or it can be drawn from box 2. Therefore, the probability that a red ball is drawn is the sum of the probability that the red ball is drawn from box 1 and the probability that a red ball is drawn from box 2. Therefore, this probability is equals to the sum of the probability of the event that is the intersection of box 1 and red plus the probability of the event which is the intersection of box 2 and red ball is chosen. According to the formula from the conditional probability, we can obtain this probability of events A intersects with B to be the probability of event A times the probability of event B given A. We can observe that each of these probability has been obtained in this diagram. Therefore, we get that the probability that a red ball is drawn is equal to 11/30. Part B, we would like to find the probability that box 2 was used given that a red ball was drawn. As a remark, it is more natural for us to first know which box is used before we know whether the color of the ball drawn is red. It is more difficult to know the probability that box 2 is used given that the red ball is drawn. But by using the Bayes theorem, it helps us to relate these two probabilities together by using this formula. And we can find this probability by using this formula that contains the more usual conditional probability with the information that first we know box 2 is used. Therefore, by the Bayes theorem, the probability that box 2 is used given that a red ball is drawn is equal to the probability that a red ball is drawn given that box 2 is used times the probability that box 2 is used over the probability that a red ball is drawn. We have all this information from the diagram. Therefore, the probability that we want to know is 8/11. Let's refer to this example. Before we discuss the solution, please read this question by yourself and think about how you would tackle this problem. Let's refer to the question. There are 3 factories that manufactures windows for the company. Factory 2 produced the most number of windows, and Factory 3 produced the least number of windows. However, the quality of the windows that factory produce are the best because it has the least probability of having defective window from Factory 2, whereas the quality of producing windows in Factory 3 are the worst because it has the highest chance of having a defective window produced from Factory 3. Now, we are given the information that the window selected is defective. We want to know which factory is most likely to produce that window. It seems that to answer this question is not so obvious, but we can answer this question by considering the following 3 conditional probabilities. First, we can consider the probability that the window is produced by Factory 1 given the information that this window is defective. The second conditional probability we consider is the probability that the window is produced by Factory 2 given that this window is defective. And we can compute the probability that the window is produced by Factory 3 given that this window is defective. And we would like to compare which of these conditional probability is the highest. Then this would be the answer to the question. So our target is to compute these 3 conditional probability. And according to the formula of the Bayes theorem, we notice that we need to compute the probability that a window is defective. So our first step is to focus on computing the probability that a window is defective. We can refer to this Venn diagram. The square represents the sample space, that is all the windows that the company manufactured by these 3 factories. Some of them is produced by Factory 1, some of them is produced by Factory 2, and some of them is produced by Factory 3. Among all these windows from each of the factory, a certain percentage of them is defective, which we have indicated those windows which are defective by this red region. Therefore, if we refer to the Venn diagram, we observe that to find the probability that the window selected is defective, it is equals to the sum of the probability that the windows comes from factory 1 and it is defective, plus the probability that the windows is produced by factory 2 and it is defective, plus the probability that the window is produced by factory 3 and it is defective. According to the formula for the conditional probability, we can rearrange it and to get the probability of F1 intersects with D, where F1 is denoted as factory 1 and D is denoted as defective, is equals to the probability of F1 times the probability of D given F1. And similarly, the probability of F2 intersects with D is equals to the product of the probability of F2 times the probability P of D given F2. And the probability of F3 intersects with D is equals to the probability of F3 times the probability of D given F3. If we refer to this diagram, we can observe that first, we have 25% of chance that the window produced comes from factory 1, and 60% of the chance that the window produced come from factory 2, and 15% of the chance that the window produced comes from factory 3. And once we know that the windows is produced by factory 1, then either this window is defective or not defective. We use D to represent windows that are defective and ND to represent the events that the window produced is non-defective. Then according to the information from this question, we notice that given that the window is produced by factory 1, the chance that it is defective is equals to 1%. Therefore, the complement, that is, given that the window is produced by factory 1, the window is non-defective, will be 1 minus 0.01, which gives 0.99. Similarly, given that the window is produced from factory 2, the probability that it is defective is equals to 0.0025, whereas the windows is non-defective, given that it is produced by factory 2, will be 1 minus this value, which gives 0.9975. And you can also deduce the following probabilities for windows that is produced by factory 3. Therefore, according to this information from the diagram, we can obtain each of these necessary probability from the information above. And altogether, this gives the probability 0.007. In other words, if we pick any windows produced among all the windows produced by the company, then the chance that the window selected is defective is 0.007. Let's proceed to obtain this free conditional probability. As a remark, it is more natural for us to know which factory produced the window first and then determine the probability that the window is defective. But it is rather unnatural for us to know that the window is defective first before we determine the chance that it is produced by a particular factory. In this situation, the Bayes theorem will be very useful for us as it helps us relate these two conditional probabilities by using this formula, which helps us alternate the given events that has occurred with the events to be occurred. Now, by the Bayes theorem, the first conditional probability that we want to obtain is the probability that the window is produced by factory 1 given that this window is defective. By the Bayes theorem, it is equals to the probability that the window is defective given the information that it is produced from factory 1 times the probability that the window produced is from factory 1 divided by the probability that the window is defective. We have already obtained this probability to be 0.007, and the probability that the window is produced from factory 1 is equals to 25%, whereas given that the window is produced from factory 1, there is 1% of the chance that the window is defective, as shown from this question. So the calculation here gives the probability of about 35.7%. Similarly, we can calculate the conditional probability with this formula as follows. And among these three conditional probabilities, we observe that this probability has the highest value. It means that given that the window is defective, it is the highest chance that the window is produced from factory 3. Therefore, factory 3 is most likely to have produced that defective window.